Okay, so in this video, I'm going to show you how to count the number of k-mers in a sequence file containing multiple sequences. So this is a FASTA file. So in order to use this code, you're going to need some code from a previous video called Create DNA K-mers in Python. And I'll have a link to that in this video as well. So once you have the list of k-mers from the previous code, which I'll show you right quick. So here's the previous code that produces all of the k-mers of a specified length. So this could be 2, there's only 16, or it could be a longer number, all the way up till 2. So we're going to do 4. K-mers of 4 long. And I showed you in another previous video how to search a single sequence for each one of the k-mers. But in this video, we're going to move on from that. We're going to do something which is actually helpful for you when you're doing an analysis of multiple sequences, such as doing some sort of association analysis, looking at how closely related two sequences are based on the number of k-mers that they have. So in order to do this, you're going to need a FASTA file that has at least 3 sequences in it. I have a sequence file here that actually contains 3 DNA sequences. And then you're going to need this code. So this code is going to use the seek.io function from the bio module. So you're going to need to do from bio import seek.io, and we're also going to use pandas data frame to store this data, store the number of each k-mer. So we're going to import pandas SPD. And then we're going to set the working directory and the working file to direct the script to look to your FASTA file to grab the sequences. In this case, I used a text file. It is a FASTA file, but it's just stored as a text file. If you actually store it as .fasta, you would have .fasta here. Then we're going to import the records. So we're going to parse the records. And then once we get a little further down here, we're going to take just particular parts of the record. We're going to take the ID and the sequence, and we're going to use those to populate the data frame and to search for the k-mers. So the sequence will be used to search. We'll search the sequence for the k-mers, and the ID will be basically the index for each of the rows in the data frame. So we're going to use a for loop, actually 2 for loops, nested for loop, in order to search all of the records. So we're going to search through all of the records. That's what this loop is saying, for I in range of 0 to the full length of the record. So we're going to search all the records. And for each one of those records, we're going to grab a name, which is going to be the ID, and we're going to grab a sequence, current seq, which is the sequence from that file. We're also going to have a list, and this list is going to be used to temporarily store the tally of each one of the k-mers. And then we're going to have another list that we're going to put the names in, and we'll use those that list there to create the index for the data frame. So for H in all of the options, so in all of the nuke options, which the nuke options are all of these k-mers. So all the k-mers that you see here, we're going to go through each one of those, and we're going to count the number of occurrences in the current seq. So that's what this code says here. It says counter, which is going to be the full tally of a particular k-mer, equals to the count from the current sequence for each one of those h's. So for the current h in this case, the loop loops through each one of them. And then we're going to use the line list. So line LST, we're going to add to it the counter each time we count for each one of those k-mers. So when it's all said and done, through going through this loop, we will have a list of each one of those k-mers, the tally for how many times each one of those k-mers occurs in each one of the DNA sequences in our FASTA file. We're then going to take and we're going to append those or add those values, that line list. We're going to add it to the K-mer data frame. So that's what this code here does. It adds one line at a time to an existing data frame. So the K-mer data frame, we're going to add the line list as a line. And then we're going to add a column to this data frame, and we're going to call that name. And for that column, we're going to populate it with the names list. Okay, so we made a names list. Each time we went through, going through each one of these records, we added a name to that list. And we're going to use that list of names to populate a new column. And then once we have that new column populated, we're going to use that and we're going to set that column as the index for the data frame. So whenever everything's all said and done, we'll have a name column, which is also going to be the index. And then we're going to have column headings up here, which are going to be each one of the different K-mers for that particular link. So in this case, we got six mers there, and I actually have it set for 4 up here. So let's redo it. Let's go ahead and run the code and see what our table looks like once we calculate it for the K-mers of length 4. Okay, so you see that it changed them to K-mers of length 4 now. We have 256 columns. So those 256 columns represent each one of the K-mers. So 256 options of K-mers. And then we have a named column, and that's the index for each one of the records. And then you can look on the down in the data frame, and you can see the tally of each one of those K-mers in the actual sequence. So this is how you count the number of K-mers in a DNA sequence. At this point, you could take this table and export it in whatever format you need it in to do a further analysis, perhaps a phylogenetic analysis using this data. One of the things that is often done with K-mer data is looking for homologs or seeing how closely related two genomes are to each other. So I hope this helps you out. I hope it gets you a little further down the line in your bioinformatic journey. If you like the video, please like it, and please subscribe to my channel. Thank you.